Hi, my name is Anthony. Today we're going to be talking about Thevenin equivalent circuits. So, what is a Thevenin equivalent circuit? Well, it's defined by Thevenin's theorem, which is a method for simplifying a circuit to an equivalent form. Basically, it states that any linear circuit containing multiple voltage sources or current sources and resistors can be simplified to a single voltage source in series with a resistor. This is especially useful when analyzing complex circuits, as you can find the resistance and voltage as seen from the selected nodes, in this case, A and B. But why use Thevenin's theorem instead of Kirchhoff's laws? Kirchhoff's laws are relatively simple to use, but can become very complicated. If you look to the upper right, this circuit on the left would be very hard to calculate using Kirchhoff's circuit laws. However, if you can reduce it to just a voltage source and a resistor, you can easily analyze the relationship between nodes A and B. So how do we create a Thevenin equivalent circuit? To do so, we have to do a couple things. The first is to remove the load resistor or the components that the Thevenin equivalent circuit is to be built around. In the diagram, this is the space between nodes A and B. The second is to short any voltage sources and to treat any current sources as open circuits. Ideally, you should do this after figuring out what the voltage difference over the removed component is, as this makes calculations easier. The third is to calculate that voltage and the resistance of the circuit from the perspective of the removed component, that is, from nodes A and B. The voltage that you calculate is then the Thevenin equivalent voltage, and the resistance is the Thevenin equivalent resistance. Finally, you can rebuild your circuit as a Thevenin equivalent by adding your voltage source, the Thevenin voltage source, in series with your resistor. In conclusion, we use Thevenin's theorem to analyze hard to analyze circuits, such as this power supply circuit. You might not necessarily know how many voltage sources or current sources or resistors are in that circuit, so it's easier to replace them with an equivalent circuit. This can be easily measured via digital multimeter, and it greatly simplifies the circuit for testing if you decide to change the load.